The circuit to the spot is considered a feeder from the main service panel to the disconnect box. Therefore, NM or Romex cable is not allowable for this circuit. You must use a type of cable approved for feeder applications, such as THWN or XHHW. The splice in a box in the attic is not allowable. Splices and feeder circuits must be done in an accessible location, such as the disconnect box itself. EMT is allowable for outdoor use if it is installed according to code provisions. This includes attaching it securely to the house or deck without contacting the ground. Compression connectors are also acceptable if they are listed for outdoor use and installed properly. There are additional code requirements that should be considered. Firstly, the disconnect box must be located within sight of the spa, not more than 5 feet away. Secondly, the spa must be bonded to the electrical system using a separate grounding electrode conductor. Thirdly, the spa must have a GFCI protection device installed in addition to the GFCI in the disconnect box. Fourthly, all wiring must be protected against mechanical damage and outdoor conditions. It is recommended to consider the following changes to ensure code compliance and safety. Firstly, install THWN or XHHW cable from the service panel to the disconnect box. Secondly, remove the splice in the attic and make the connection in the disconnect box. Thirdly, bond the spot to the electrical system using a grounding electrode conductor. Fourthly, install a GFCI protection device on the spa itself. Let's delve deeper into each of these points to ensure a comprehensive understanding of the electrical requirements for installing a portable spa. We'll start with the circuit type and cable selection. The National Electrical Code, or NEC, distinguishes between branch circuits and feeder circuits. A branch circuit extends from the final overcurrent protection device, which is typically a circuit breaker, to the outlets or equipment being supplied. A feeder, on the other hand, is the circuit between the service equipment, such as the main panel, and the final branch circuit overcurrent device. In this case, the circuit supplying the spa is a feeder because it runs from the main service panel to the disconnect box, which contains the overcurrent protection for the spa. Given that it's a feeder, NM or Romex cable is not suitable. NM cable is designed for dry, interior locations and is not rated for outdoor use or for direct burial. The NEC requires that feeders be wired with cables suitable for the environment and application. Acceptable alternatives include THWN, which stands for thermoplastic high water resistant nylon coated, or XHHW, which stands for cross-linked polyethylene high heat water resistant. These cables are rated for wet locations and can be installed in conduit or direct buried, depending on the specific type and installation requirements. When selecting THWN or XHHW conductors, ensure they are sized appropriately for the load and the overcurrent protection device. Refer to NEC Table 310.15b16 to determine the allowable ampacity of conductors based on their size and insulation type. Remember to account for voltage drop, which can occur over long distances and reduce the performance of the spa equipment. Next, let's address the splice in the attic. The NEC generally prohibits splices in concealed locations, such as attics or walls, unless the splice is accessible. An accessible location means that the splice can be reached without damaging the building structure or finish. The reasoning behind this rule is to ensure that splices can be inspected and maintained if necessary. In this scenario, the splice in the attic is not considered accessible because it would require accessing the attic space. Therefore, it's not compliant with the NEC. The proper solution is to eliminate the splice and run a continuous length of THWN or XHHW cable from the service panel to the disconnect box. If a splice is unavoidable, it must be made in an accessible enclosure such as the disconnect box itself. When making splices, use connectors that are listed for the type of conductors being joined and install them according to the manufacturer's instructions. Wire connectors should be properly tightened to ensure a secure and reliable connection. Now let's discuss the use of EMT, or electrical metallic tubing, for outdoor applications. EMT is a thin-walled steel conduit that is commonly used for protecting electrical conductors. It's a cost-effective and versatile wiring method, but it must be installed correctly to ensure its suitability for outdoor use. The NEC allows EMT to be used outdoors, provided that it is supported and secured properly. EMT must be supported at intervals not exceeding 10 feet, and within 3 feet of each box or fitting. This ensures that the conduit is rigid and protected from physical damage. Additionally, EMT fittings and connectors used outdoors must be listed for wet locations. These fittings are designed to prevent water from entering the conduit system and corroding the conductors. Compression connectors, which are commonly used with EMT, are acceptable for outdoor use if they are specifically listed for that purpose. It's important to ensure that the connectors are properly tightened to maintain a watertight seal. When installing EMT outdoors, avoid contact with the ground. Direct contact with the earth can accelerate corrosion of the conduit. Instead, support the EMT on non-metallic standoffs or hangers to maintain a separation from the ground. Now we will examine the additional code requirements that relate to the spa installation. The disconnect box must be located within sight of the spa, not more than 5 feet away. The purpose of the disconnect is to provide a readily accessible means of shutting off power to the spa in case of an emergency or for maintenance. The NEC requires that the disconnect be within sight of the spot to ensure that the person operating the disconnect can visually confirm that the power is off before working on the equipment. The 5-foot distance limitation is intended to keep the disconnect close enough to the spot to be easily accessible, but far enough away to prevent accidental contact with the water. The spa must be bonded to the electrical system using a separate grounding electrode conductor. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that in the event of a ground fault, the fault current will quickly trip the overcurrent protection device, minimizing the risk of electrical shock. In the case of a spa, the metal parts that must be bonded include the spa equipment, the metal frame of the spa, and any metal piping or equipment associated with the spa. A separate grounding electrode conductor must be run from the spa equipment to a grounding electrode, such as a ground rod or a metallic water pipe. This grounding electrode provides a direct connection to the earth, which helps to dissipate fault current and further reduce the risk of electrical shock. The NEC requires that the grounding electrode conductor be sized according to NEC Table 250.122, based on the size of the circuit conductors. The spa must have a GFCI, or ground fault circuit interrupter, protection device installed in addition to the GFCI in the disconnect box. A GFCI is a device that monitors the current flowing in a circuit and quickly interrupts the power if it detects a ground fault. A ground fault occurs when current leaks from a conductor to ground, which can happen if the insulation on a wire is damaged or if there is a short circuit. GFCI protection is required for spa circuits because of the increased risk of electrical shock in wet environments. The NEC requires that all spa circuits be protected by GFCI. In this case, a GFCI is already installed in the disconnect box. However, it is recommended to install a second GFCI on the spa itself. This provides an additional layer of protection and helps to ensure that the spa is safe to use. All wiring must be protected against mechanical damage and outdoor conditions. Wiring that is exposed to the elements or that is subject to physical damage must be protected by conduit or other means. In this case, EMT is used to protect the wiring from the disconnect box to the spa and to the outdoor outlet. EMT provides a durable and weatherproof enclosure for the conductors. The EMT must be supported and secured properly to prevent it from being damaged. Additionally, the wiring inside the EMT must be suitable for outdoor use. THWN or XHHW conductors are commonly used for this purpose. Now we will consider the specific recommendations to ensure code compliance and safety. The first recommendation is to install THWN or XHHW cable from the service panel to the disconnect box. As previously discussed, an M cable is not suitable for this application because it is not rated for outdoor use or for use in wet locations. THWN or XHHW cable is a better choice because it is designed for these conditions. When installing THWN or XHHW cable, be sure to follow the NEC guidelines for conductor size and ampacity. The cable must be sized appropriately for the load and the overcurrent protection device. The second recommendation is to remove the splice in the attic and make the connection in the disconnect box. Splices in concealed locations are generally prohibited by the NEC unless they are accessible. In this case, the splice in the attic is not accessible, so it must be removed. The proper solution is to run a continuous length of THWN or XHHW cable from the service panel to the disconnect box. If a splice is unavoidable, it must be made in an accessible enclosure, such as the disconnect box itself. The third recommendation is to bond the spot of the electrical system using a grounding electrode conductor. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that in the event of a ground fault, the fault current will quickly trip the overcurrent protection device, minimizing the risk of electrical shock. The fourth recommendation is to install a GFCI protection device on the spot itself. A GFCI is a device that monitors the current flowing in a circuit and quickly interrupts the power if it detects a ground fault. GFCI protection is required for SPA circuits because of the increased risk of electrical shock in wet environments. By following these recommendations, you can ensure that your SPA installation is code-compliant and safe. Remember to consult with a qualified electrician if you have any questions or concerns. A professional electrician can help you to ensure that your SPA is installed correctly and that it meets all applicable electrical codes. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Improper electrical work can be dangerous and can lead to serious injury or death. In summary, ensuring the safe and code-compliant installation of a portable SPA involves careful attention to several key factors. Firstly, selecting the correct type of cable for the feeder circuit, specifically THWN or XHHW, is crucial for outdoor and wet locations, unlike an end cable which is unsuitable. Secondly, avoid making splices in inaccessible areas like attics. Instead, run a continuous cable or make splices within an accessible enclosure such as the disconnect box. Thirdly, when using EMT conduit outdoors, ensure it is properly supported, utilizes connectors listed for wet locations, and avoids direct contact with the ground to prevent corrosion. Fourthly, adhere to specific code requirements such as positioning the disconnect box within sight and no more than 5 feet from the SPA. The bonding of the spot of the electrical system with a dedicated grounding electrode conductor is essential for safety. In addition to a GFCI in the disconnect box, install a secondary GFCI on the SPA itself for enhanced protection. Lastly, protect all wiring from mechanical damage and outdoor elements. Following these guidelines and consulting with a certified electrician ensures a safe and compliant SPA installation, minimizing electrical hazards and adhering to NEC standards.